Problem number 10. I tell you about u and v, and I give you the dot product of u and v, the dot product of u and u, and the dot product of v and v. So what can we tell about u and v here? By the way, note my nice big stack of paper. I just went and got some more paper here. First thing, absolute value, I should really say the magnitude of u. Well, how do we find this? Remember that u dot u is equal to the magnitude of u squared. And so if I told you that u dot u is equal to 81, the magnitude of u is equal to the square root of u dot u is equal to the square root of 81 is equal to 9. So u has length 9. For part B, asked about 3u minus v, dot product with u plus v. And when we distribute out this dot product multiplication, we have 3u dot u minus v dot u plus 3u dot v minus v dot v. So u dot u is here, v dot v is 25, u dot v is 45 over 2. And then dot products are commutative. So v dot u is equal to u dot v. Cross products are not commutative, but dot products are commutative. So this is 3u dot u minus u dot v plus 3 times u dot v is plus 2 times u dot v minus v dot v. And so now we can plop in all of these things here. 3 times 81 plus 2 times 45 over 2 minus 25. So this is 243 plus 45 minus 25. If my mental math is correct, that's 263. Part C here, what's the angle in radians between u and v? Well, for that one, theta is going to be, theta is, let me say here, cosine theta is equal to u dot v divided by the length of u times the length of v. Let's see here. So what do we have? U dot v is 45 over 2. The length of u is 9. The length of v, by the same argument that the length of u is the square root of 81, the length of v is the square root of 25. So cosine theta here is 1/2. What does that tell us about theta? This is a case where we can determine theta without, exactly without having our answer involve inverse trigonometric functions. Theta is pi over 3. Okay, and then the final one here, this is a clever, punchline to everything. What's the area of the parallelogram with sides u and v? So the picture here is u, here is v. We want to find the area of this parallelogram. And the area of this parallelogram is equal to the magnitude of u cross v. Now, this might seem difficult to do because we don't have information here. I gave you information about the dot products, not the cross products, but there is something we can do here. And the thing that we can do is realize that there's a connection, there's a formula for, so just like we know that u dot v is equal to magnitude of u, magnitude of v times cosine theta, the length of the cross product, the length of u cross v, is given by the magnitude of u times the magnitude of v times sine theta. It's good to know these two formulas, how they kind of work in parallel here. And so this is exactly our area, is the magnitude of the cross product. So we don't actually have to know the cross product here. We can just go straight to things that we know about. The magnitude of u is 9, the magnitude of v is 5, and times sine of pi over 3. And sine of pi over 3 is going to be root 3 over 2. So this is 45 root 3 divided by 2, and that's our final answer here.